Hi, today we make a deep dive into the low-code platform Langflow, which allows you to build LLM-based applications without coding yourself. Compared to the other platforms, it's my clear favorite, mainly because it's Python-based and you can easily add your own functionality. And of course, it has an MIT license. This means that you can further develop it and earn money with it without any problems. As always on this channel, we start with the very basics to build a simple application and then move on how to build your own components, how to export workflows, and how to set up a production-grade setup with Postgres, LangFuse, and Langflow. As always, you can get the link to the repository in the description. Okay, so I'm now in VS Code, and here you can see on the left is nothing. We just got an open terminal and we'll set up the environment to work with Langflow. It's quite simple. I would recommend that you use UV to set everything up. So we will first create a virtual environment with UV event. Now we've got our virtual environment. Okay, that looks weird. Just have to copy that and now activate the virtual environment. Next step is that we use it. So we use UV pip install Langflow -u. This will install all of the dependencies, the newest dependencies from the package. This may take some time because Langflow has got a lot of dependencies. After installing Langflow, we can use the Langflow CLI and just run UV run Langflow run. So this will now start the server, and after a few seconds we will be able to see Langflow in the UI. Langflow per default will spin up a SQLite database to store the components, to store the interactions and everything. This is nice for development, but later we will also see how a production setup looks like with Docker Compose. So here we are at localhost port 7860 and we can create our first flow. Just click on this button, create first flow, and here we can select from a lot of different templates, but we will start with a fresh template. So we can click on blank flow. So we can explore the components that we have to use to create our very simple first chat application. Okay, so we will start with the most important components, which are input and output components. We got text input and text output, but you will probably use chat input and chat output most of the time. So chat input is when you type something and this will be processed from that component to another component, and then you link all of the components. So in the very simple use case, we just connect the output from the chat input component to the chat output component. So this means we got our first application, which is an echo application. We type hi and the output will always be the same. So this is how this works. Of course, not very useful. So we will just delete that session. And what we do now is we will use some logic here. Okay, so what we want to build is a simple chat application. This means that we have to pass the chat input to an LLM and the output from the LLM to the chat output component. So what is also very nice to have is to have a prompt template with a system prompt for the LLM. And to be honest, I have no idea where this is here. So what's nice is that you have the search bar where you can just search for component. In this case, we find this prompt template and we can import it. So as you can see, this prompt template component has nothing on the left and one blue button here on the right. So what does this mean? On the left are always the inputs. On the right are always the outputs. So this prompt template you can type a prompt here. For example, a system prompt. You make always very funny jokes. So that is the system prompt for the LLM. We could also provide some prompt variables here. In our case, we don't need one. And now we want to pass the prompt and the chat input to the LLM. So we want to use an OpenAI model. So I will just search for OpenAI. So this is an OpenAI component. I will just import it from there. And you can see we've got two inputs. We've got the normal input and the system message. So this is exactly what we have. We've got our prompt. So we will remove first that link. You can just remove it. And now we've got the chat input. This will be passed here. And as you can see, now you can not enter anything here anymore. And we pass this like this. Okay, so we've got our input, our two inputs, and the model response. So we will link the model response to the chat output component. To use an OpenAI model, you of course need your own API key. And as you can see, this is not something that you want to enter in plain text, but there is a variable that already is suggested, that is the OpenAI API key environment variable. And if we just use the playground, then we of course can see that this variable is not set. incorrect API key provided. So how can we fix that? First, we're gonna click here on dismiss, and to actually set an API key, we have to go to settings, and then we have to set global variables. So in this case, we can do it like this, add a new environment variable. In this case, we can use a generic variable or credentials. For an API key, you should use type credential, and here you could enter the name and the value. So this is one way that you can use, but to be honest, there is a better one. The, in my opinion, preferred way to do it is that you first stop the server, and then you create a .env file, and in here you set your OpenAI API key. And here you paste the OpenAI API key and save it. And now you can start the server again, but this time you will set a new flag, which is --env -file and then .env. So this will automatically load all of the environment variables from your .env file. This is much better than setting it in the UI. If we now use our flow again, then we can just type hello, and this time we should not get an error. This time the LLM answers, hello, how can I brighten your day today? Not very funny, but we can see the response still works. Okay, so let's assume that this chat application is something that we want to bring to production. How can we actually do this? Since we don't want to let any users just go to our website and use this chat playground UI to interact with our flow. So the way to do that is to share that flow, and you've got two options. You've got the option to use it as MCP server. So if you want that chatbot that you built and use it as another tool for another LLM, then use this MCP server. You can also use API access, and this will give you directly a link with the URL you are running on, then /API v1/run, and then at the end a UUID. So that is the UUID for our flow, which is stored in a database, and we need that ID to actually make it possible that we've got maybe even thousands of different flows. And that is the unique identifier in our database. So what we send to this API is the following. So we've got a dictionary with output type and input type. Since we used chat input and chat output, this will be of type chat, and the input value is what we just typed in the UI. We've got also a session ID, and this session ID is used when you've got, let's say, chat memory. So some applications got that, and you can extract the session ID to identify the user or chat session that this request belongs to. So we can just copy that and then create a new file here, call it script.py, paste it here. We open a new PowerShell, and one thing is wrong, and that is headers. So we've got headers here in as variable, but we actually don't have any headers above that. So we can just remove that, and we're just gonna run run Python and then script.py. And now we can see that this does not work. We get a 403 client error forbidden for URL. So why does this happen? In this case, we are not logged in, but in the UI, we are logged in. So we need some kind of credentials to fire against this API. So what we have to do is to actually set the headers again. And now for this header, we have to provide a specific value, which is the API key. So how can we do that? We first have to go to settings again. And now go to Langflow API keys, create a new API key. And here we can just create a simple API key like this, and we can just copy that. And I would normally recommend that you also save that in a .env file or somewhere, or in some kind of key vault. But in this case, it doesn't really matter since it's just for local development. So we copy that and then we use it here. So this is the way the headers should look like. So a dictionary with content type and then X minus API key, which is the custom header for the API key. And then if we try that again, we can see that if we run run Python and then script.py again, then this time this works. So that is the result from our API. As you can see, there's a lot more than compared to the UI. We can see the input type here is input hello world, and then output is of type result, and this is a nested dictionary. We can see sender machine, sender name, AI, and a lot of different stuff like the model that was used and everything that we need. So in this case, output type is hello, how is it going on in your corner of the universe? So a lot of additional information that you can use for whatever you want. Okay, so let's say we are now happy with our product that we just built and want to bring it to production. How can we do that? Everything was built locally. So we've got our API, which only can be accessed locally, but how can we change that? So the best way to do that is to just export our flow. So you can click on share and then on export. And for this type, you can just give it a name, greatest flow ever. And you can save it with your API keys or you can save it without your API keys. I would normally recommend that you don't save it with the API keys because your production grade setup will use a different API key that might be somewhere else. So you don't want to save it. So in this case, let's just export it. And this will now look like this. So our flow is a JSON file that will be interpreted by Langflow as graph. And this can be imported now in a different Langflow instance. And this is what we're gonna do. So we now gonna use that flow in our production grade setup, which you can find in the repository in the link below. Okay, so this is the production grade repository and there is a lot of stuff going on. Let's first have a look at the infrastructure. So that is in the Docker Compose YAML. So we've got multiple services and we've got a Langflow container, we've got a Postgres container, we've got another Postgres container, and we've got LangFuse. So LangFuse brings observability to the table, which allows us to track the flows in Langflow. It is very nicely integrated. And we've got two databases to store everything in Postgres and not in a SQLite database, since Postgres is just much more mature and production ready in comparison to SQLite. Okay, so this is our setup, but how can we now use the greatest flow ever that we developed in our development environment? How can we use that in this environment? So Langflow gives us one environment variable. And if you have a look at the docker.env.example file, then you can see that we've got multiple variables here. And important here is the Langflow underscore load underscore flows underscore path variable. And we reference this /app/flows path. So everything has to be inside that path. So to achieve this, we first have to create a new directory. In this case, we just call it flows. And we put all of the JSON files, in this case, we only got one, files inside that directory. And then in the Docker file, where we use our Langflow server, so we can also use the Langflow image here, we will create two directories. So this for flows, and then we'll just copy our local flows folder in that directory /app/flows. And this makes it available for our Langflow instance. So let's try this out. So you can just type docker compose up --build. So this will download all of the available images and start the server. So for you, this might take a little bit longer since you have to download all of the images like Langflow, the Postgres databases and so on. But in my case, now everything is started and we can go to our URL again. Okay, so I'm now again at localhost 7860. And as you can see, we've got our greatest flow ever again. But this time we are now at the production grade instance, which is connected to LangFuse. So pretty easy to develop somewhere else and then just export it and use it in a production grade setup. But I know you might say, yeah, this was just too easy, you're just using the same website. But in this case, I can prove you wrong. As you can see, we've got two more components, which are study tools and the research helper. So this was not there before. And this is something that I'm going to show you now, how you can create your custom components. So first I'm going to show you that in the UI. So we'll just delete that flow. So we've got that component. We can see we've got two inputs, prompt or question, and then supporting context and one output. So how can we actually build something like that? For custom components, it makes sense to create a new folder like for flows. So in this case, I just call it components, and inside there, we got more folders, research helpers and study tools. As you can see, this name of the folder exactly matches the name of the tools here. So inside that folder, we've got Python files. So we're gonna have a look at the study tools. So the study node composer.py. This makes use of a special class from Langflow, langflow.custom, and we have to import the component class here. And we have to inherit from that component class to get all of the functionality from Langflow and set our functionality on top. So the first 4 class attributes are for the UI. So we've got a display name, study node composer, a description, which is a text below that, an icon, in this case we use a notebook pen, and also an internally used name for our custom component. Then we've got multiple types of input, which I show you here. So we've got a message text input, a multi-line input, and an str, so a string input. 3 different inputs, and these have to also be imported from langflow.io, and these will be displayed on the left. So you can see we've got 4 inputs, these 4 inputs, and if I look at the UI, then you can also see these 4 types of inputs: the prompt, the supported context, the learning goal, and the tone, which is of type dropdown. So this exactly is what's happening here. So this is a list, very important, a list of inputs, and the same applies for the outputs. We also got a list of outputs. In this case, it is only a single output, but it still has to be wrapped around in this outputs list. So for the output, we've got the name, the study node, a display name, and then very important, a method. So this method attribute only applies for output, since we want to take input and then apply a method on that and output the result via this output component. So what is also important to know how to actually access the inputs. So this can be done with self. So this will be stored in an instance variable. So self.prompt matches exactly the name of this input. The same applies here, self.context, self.learning goal, and self.tone. All are the names of these inputs here. And then we can do whatever we want. In this case, there is nothing really special going on. Actually, it's just a little string formatting that we do with this component, but I guess it's nice for a demo purpose. So this is how that works. And now we want to use the custom components. How can we do that? Again, we have to use the correct environment variable. So in the docker.env example file, you can see that we also got this environment variable, langflow _ components _ path. And this is app/components. And we also have to set it in the Docker file. So we're gonna create this folder, and then we copy our components folder, so the local components folder, in that directory. And now this will make it accessible for Langflow to use our custom components. Okay, so the last thing that I want to show you is the integration of LangFuse, which is pretty easy and pretty awesome. So in the docker.env.example file, you can see we've got 2 variables, the LangFuse secret key and the Langflow public key. So Langflow is running on port 3000. This is also a variable that we have to set. So this is how this is connected. So let's go to localhost port 3000, and then we are in LangFuse. So you connect a LangFuse project to our Langflow flow. So we create a new project, you can call it whatever you want, create it, and then you get your API keys. And then you just copy that variable, the secret key, and paste it here. And you do exactly the same for the public key. And after that, you're just gonna save that. Okay, so after creating your API keys, we now want to use it. And what we first have to do is to stop our instances and then start the server again. So otherwise, LangFuse will not know about the updated keys, or Langflow will not know about the updated keys, and then we can use it. So first, we just go back to our project. You can see that is my test API. We go to that project and we don't have any traces yet. So now we want to use that simple flow. Go to the playground, create a new session, and just type hi. So nothing really specific. And now if we go back to our dashboard, we can press update, and now we can see we've got the traces. So I had to do it 3 times because the first 2 times it was not displayed in the UI. But this is how it works. You can see all of the traces and all of the inputs. I think this is just great. You can go very deep. You can see the sender, the flow ID, the model that was used, everything that we normally only have in Langflow is now also available in LangFuse. And this makes tracing much easier. We can see how long the OpenAI model took to answer. We can see how many tokens were used and an estimated model cost. So pretty awesome in my opinion. Okay, so that's it content-wise, but I also wanted to give a little outlook on Langflow. So where is Langflow going? So the package itself is quite heavy, and they promised a more streamlined package management system. So if that means you got no interest in ChromaDB as VectorDB, you should not be forced to install it, but it should be optional dependency, since otherwise that makes your image quite large, and also more packages normally mean more vulnerabilities, where Langflow had quite a few in the last month. So definitely that would be a great improvement. Also something that I came across is the LFX package, the Langflow executor package, that is currently not in the documentation. So I found it just in the source code in the GitHub repository. So there is already a README, but it's not in the official documentation. So it should make the flow execution much easier. So you get LFX serve and you can run your flow as an API. You run LFX serve and then the name of your flow. So this will create a fast API server with the flow available at the normal path. So flows, then the flow ID and then /run. Since it may make the execution of a flow much easier and more streamlined. So in my opinion, an already great package may even get better in the future. So if you did not use it already, then definitely something that you want to try out. Thank you very much for watching. See you in the next video. Bye bye.